Well, I hope your concentration isn't flagging as we get to question 3, because it's all about concentration. I know I've made that joke before, but it's still, to me, is very funny. Now, we have this time a little h next to the number. That just indicates that this is higher only. So if you are sitting the foundation paper, again, you don't need to worry about this question. You don't need to watch this. Do something else with your time. If you are sitting higher and you want to know how to calculate concentrations involving moles, well, sit back and enjoy. So we are told in this question that we've got 2.4 moles of calcium nitrate and 2 decimeters cubed of distilled water, and we need to calculate the concentration in moles per decimeter cubed. Now, the units of concentration give us a lot of information about how to do the calculation, because all concentration is a measure of is how much of something there is in a particular volume. Now, beforehand, we have done this with masses. So how much of a particular mass there is dissolved in a certain volume, but now we're doing it with moles. So we're looking at the amount of substance dissolved in that volume. So all we need to do to find the concentration is take the number of moles and divide it by the volume. But we just need to make sure that our volume is in the correct units of decimeters cubed. So with this one, we've got 2.4 moles. We're dividing it by the volume, which is 2 decimeters cubed, which gives us an answer of 1.2 moles per decimeter cubed. Okay, that's all we need to do there. It's worth a mark, job done. So just moles over volume. Looking at the second part, part B, this time we're told that the number of moles is 0.5 moles, but we are told that this time we've got 800 centimeters cubed of water. Now the problem here is that centimeters cubed is not decimeters cubed, so we need to do a unit conversion in order to calculate our concentration. Now the way that I remember this, so 1 milliliter is exactly the same as 1 centimeter cubed. So if you're measuring anything in milliliters, that's what a centimeter cubed is. A liter is equal to 1 decimeter cubed. Okay, and we know, or hopefully you know, that there are 1000 milliliters in 1 litre. So therefore, what that means is that there are 1000 centimeters cubed in 1 decimeter cubed. So to convert centimeters cubed into decimeters cubed, what you need to do is you need to divide your answer by 1000. So 800 divided by 1000 gives us 0.800. And if you've done that conversion, that will give you the first mark here. Okay. Now the second thing you need to do is you need to do your concentration calculation like we saw before. So concentration equals mole over vol, moles over volume, number of moles 0.5, volume 0.800, and if you do that calculation you get an answer of 0.625 moles per decimeter cubed. And that's your second mark, so that's worth 2 marks rather than just the 1. You get that extra mark for doing the little bit of unit conversion that you've got to do there. Part C, this time we're flipping the question a little bit. So this time we're actually told the concentration is 1.5 moles per decimeter cubed. I'm just going to write that there. We're told the student has got 600 centimeters cubed of water, so I'm going to write that in there as well. And we need to calculate the number of moles that they need. So we don't know the moles this time. Okay, so that's what we're trying to deduce. Now, the first thing that we've got to see here is that this is a question that is worth 2 marks, once again. Might even be worth 3 in an exam, but we've said here it's worth 2. And the first mark is going to be for realizing that once again your volume is in centimeters cubed. So we're going to need to convert that into decimeters cubed, and to do that, once again, we need to divide by 1000, which gives us an answer of 0.600 decimeters cubed. We'll say that's worth a mark. Now, the concentration, as we said before, was equal to the moles divided by the volume. Now this time, we are trying to calculate the number of moles. So we need to get that on its own in the equation. So we need to move volume over to the other side. Well, currently, because it's being divided by volume. To move it over, we need to multiply both sides by the volume. So therefore, volume times concentration is equal to our number of moles. Brilliant. So if we substitute our numbers in, we can do that calculation. So 0.600 is our volume. The concentration is 1.5. And if you do that calculation, you'll get an answer of 0.9 moles. Second mark. So if you get 0.9, brilliant, you've done it absolutely spot on. You just needed to do a little bit more rearrangement than you've had to do before. D, very similar to the previous one. Rather than calculating moles this time though, we are calculating the volume of distilled water, and it does ask us for it in centimetres cubed. Now we're given the concentration of the solution in moles per decimetre cubed, and we're told how many moles we've got. So I'm just going to make a note of those two values because I'm probably going to need to use those, and it's good practice to write those bits down to scribe. So number of moles is 0.05 mole. There we go. So thinking about our equation from before, concentration equals moles divided by volume. Now we want to get volume on its own on one side. Now because it's on the bottom of the equation here, it's under that line it's being divided by, we can't just do this in one step. So what we're going to have to do first is do what we did before, multiply both sides by the volume. So concentration multiplied by volume is equal to the number of moles. Now we've got it above that line, so we can do some more manipulation to get it on its own. At the moment, it's being multiplied by concentration. We want concentration, therefore, to go to the other side of the equation, and in order to do that, we can divide both sides by the concentration. So we end up with volume being equal to the moles divided by the concentration. So therefore, what do we need to do? Well, our number of moles we've already written was 0.05. Our concentration was 0.2. If you do that calculation just there, then what you get is 0.25 decimeters cubed. That's all well and good. However, the question has asked us to convert this into centimeters cubed. So to go from decimeters cubed into centimeters cubed, what we need to do this time is the opposite to what we did in the previous questions. We need to multiply our answer by 1000, and 0.25 multiplied by 1000 gives us an answer of 250 centimeters cubed. Now this is worth 3 marks in total, this question. So you'll get 1 mark for doing the rearrangement. You'll get a mark for, sorry, is it worth it? No, it's worth 2, sorry. You'll get 1 mark for doing the rearrangement there, and then you get 1 mark for getting your final answer. So getting the 250 at the end. Sorry, it's worth 2 marks. Now we move on to E. A little bit more work has to be done here. We're told a student wants to make up a solution with this concentration. So I'm going to write that down. 0.4 moles per decimeter cubed. And we're told the student has got 600 centimeters cubed of water. Cool, write that down. And we need to calculate this time the mass. So there's an extra step this time. That's why we've got an extra mark available for this question, because we're not finding moles anymore, we're finding the mass. So this not only requires us to use the equation relating concentration, moles, and volume, but it also requires us to remember the relationship between the number of moles and the mass and the relative formula mass. So I'm just going to make a note of that over there, because remember, a mole is equal to, or the number of moles is equal to the mass of a substance in grams divided by its relative formula mass. So that could be its relative atomic mass, it could be its relative molecular mass, whichever. So going on from there, the first thing we can do is find out how many moles we've actually got. So we're going to need to convert these centimeters cubed into decimeter cubed, same way as we've done before, dividing by 1000. So that gives us 0.600. Give yourself a mark for that. And then we are trying to find the moles. So in order to do that, we have to rearrange this equation, which we need to get volume over to the other side. So we need to do the opposite of what it is at the moment. So it's dividing. So we need to do concentration times by volume. Now, that means if we substitute the numbers in, 0.4 multiplied by 0.600, we're going to get an answer of 0.24 moles. That'll be worth a mark, surely. But it's not the number of moles that we're trying to find. It is the mass of lithium nitrate. So what we need to do is we need to find the relative formula mass of lithium nitrate, because we've already got the moles, and then we can rearrange this to find the mass. So the relative formula mass of lithium nitrate is going to be lithium has an atomic mass of 7, nitrogen is 14, then there are 3 lots of oxygen, so 3 lots of 16, which is equal to 69. Now, if we look at this equation, we need to rearrange it in terms of mass. We need to move relative formula mass over to the other side, and it's being divided by at the moment, so we need to do the opposite, so we need to multiply. So therefore moles times the relative formula mass is going to be equal to the mass that we need. So our number of mole is 0.24, the relative formula mass 69. We multiply those two numbers together and we get 16.56 grams. This question does not ask us to give it to any particular number of significant figures or decimal places, so I'm going to leave my answer as 16.56. Okay, if you did that, that would be your third mark. So there's only one more question to look at as part of question 3 on concentration, and we're told the solution of magnesium chloride MgCl2 has got a concentration of 0.120 moles per decimeter cubed. I'm going to write that down. And what I'm going to need to do is I need to calculate the concentration of the solution in grams per decimeter cubed. So essentially I'm just converting the unit of concentration. Now again, this requires us to remember that equation that relates moles with mass with relative formula mass. So moles is equal to mass in grams divided by the relative formula mass. That's all well and good. We're happy with that. Okay, but this time we've got the added complication of concentration, but it doesn't actually need to be overly complicated, because if you've got a certain number of moles in 1 decimeter cubed, which is what this is telling us, moles per decimeter cubed, you can figure out how many grams there are in 1 decimeter cubed by just converting using the equation we've got on the right hand side. So I'll show you what I mean. So we're trying to find the mass, so we need to rearrange this equation. We're going to do that exactly as we did before. Mass is equal to moles times the relative formula mass. We need to find the relative formula mass for MgCl2. So we're going to do that very quickly. So for magnesium, it's got a relative atomic mass of 24. Chlorine is 35.5, but there are 2 of them. So it's 2 lots of 35.5. If we do that, we get an answer of 95. That would be the mark. Oh, I say it would be a mark. No, I've only said it's worth 1 mark. Again, I'm being really stingy with my marks. Okay, so it's probably worth marking in an exam, but I've said no, it's not. But we found 95. That's the relative formula mass. So if we take the mass, well, that's what we're trying to find, the moles, so that is 0.120 moles, and we times that by 95, what you get as an answer is 11.4 grams. And what we're saying here is if you have 0.120 moles in a decimeter cubed, you're going to have 11.4 grams in a decimeter cubed. Okay, so we're just using that same conversion, except we've got that per decimeter cubed on the end of it. Okay, there's no difference between the two really in terms of the actual manipulation of the numbers that you're doing. Hopefully that makes sense. Thank you very much for listening.